right, so now we want to look at the graphics of a firm that is trying to figure out whether or not they should produce or shut down because they are having a negative economic profit. So we start out with our graph like so. Have our demand curve, which is equivalent to our marginal revenue curve. And so let's say that's at a price of $1. We need our marginal cost curve so that we'll know how much the firm should produce. So let's say that that is 10 units of output. So again, we can calculate here that total revenue equals price times quantity equals 10. So we have total revenue of $10 at this point. Now we need our average total cost function, so we again can see what the firm's profit or loss is. So let's say, for example, it looks something like that. So now we can see where we intersect our average total cost curve at 10 units of output. That's way up here. So let's say that each unit of output again is costing us $1.50. So to figure out total costs, we would simply do the average total cost times quantity of output. And so average total cost, $1.50 times 10, $15. So we know right now the firm is having negative economic profit because you would simply do the total revenue, which is $10, subtract the total cost, which is $15, and you're left with -5. So this firm is having negative economic profit if they are producing in the short run. But remember, we're trying to figure out, would they have a loss that is smaller if they just decided to shut down instead? So we need our average variable cost function on this graph to figure that out. So let's say, for example, our average variable cost function was right here. So again, we look to see where do we intersect our average variable cost function, which is right here, because that will tell us how much each unit of output is actually costing us in terms of just the variable cost. So let's say the average variable cost per unit was 80 cents per unit. Well, again, graphically, we can already tell the fact that our price is above the average variable cost, remember, because the average variable cost is our shutdown price, then we will continue to produce, because not only are we charging enough money to cover our variable cost, which is 80 cents, but we have an extra 20 cents left over to help go towards our fixed costs. So let's look and see what our loss would be if we decided to shut down. In other words, we know that our total cost was 15. We just figured that out down there. So total cost, again, was just average total cost times quantity of output, which was 15. And now we know for our variable costs, to calculate our total variable cost, we just take our average variable cost and multiply it by our quantity of output. And in this case, our average variable cost is 80 cents per unit. Pen to work, 80 cents times 10. So 80 cents times 10, that's going to be $8, right? And we know that variable costs plus fixed costs equal total costs. So now we're just basically solving for X. We just learned that total cost is $15, variable cost is $8, so 8 plus what equals 15? That would be 7. Meaning that our fixed costs are $7. So if we shut down, we have to pay our fixed costs no matter what. Those are fixed. They are not dependent upon output. So if we shut down, we will lose $7. But if we continue to produce, we only lose $5, right? So that's why we will continue to produce in the short run, because our loss would be greater if we continued to, or if we shut down, because our fixed costs would exceed what the loss would be if we continue to produce. Remember, because we're charging 80 cents, or our variable costs are 80 cents, but we're charging $1. So we have more than enough money to cover our variable costs plus the 20 cents left over to help cover some of our fixed costs. So again, the average variable cost is our shutdown price in the short run. If we don't make enough money to cover our variable costs, we will shut down. But in this case, we do. Therefore, we will continue to produce in the short run.